In this video, we are going to talk about the power of 10. What is a power of 10? Well, simply put, it's just when 10 is multiplied by itself a certain number of times. And it looks a little like this. 10 to the power of 1 is just 10 one time, which is 10. 10 to the power of 2 is 10 times 10, which is equal to 100. 10 to the power of 3 is just 10 times 10 times 10, or 1,000. And lastly, you can see 10 to the power of 4 is just 10 multiplied by itself 4 times, or 10,000. All of these numbers are showing the exact same number in different forms. So for example, this 10 to the fourth power is the same number as 10,000, but it's written in exponent form, with 10 as the base and 4 as the exponent. This middle form is called expanded form, where we're seeing those 10s expanded to see how many there are that equal our final form, which is standard form, the way that we normally write numbers. But there's this really cool pattern that exists with power of 10s between the exponents and the zeros that occur in the answer. Do you see it? As I'm circling the exponent of 3, for example, there are 3 zeros in that standard form power of 10. Or the 4 exponent, 10 to the power of 4, and there are 4 zeros in that power of 10. The key idea here being that with power of 10s, every time an exponent increases by 1, you're going to add another 0. And this shows up all over the place because of our base 10 system. When we multiply numbers by a power of 10, we can see a pattern between the number of zeros in the multiplication problem and in our final answer. When I'm multiplying by 1,000 here, I'm getting 3 zeros in my answer, and when I'm multiplying by 10,000, there are 4 zeros in my final answer. This will help me rewrite problems with powers of 10. So my first example up here, 72 times 100, I could rewrite that as 72 times 10 to the power of 2. Or 36 times 1,000 is the same as 36 times 10 to the power of 3. Again, we're seeing this relationship between the number of zeros and the power in the power of 10. Now, at this point, you might be asking, why does this even matter? This is super helpful when we're writing very big numbers that have many zeros. Let me give you a couple examples. The population of the United States is 348 million. Do you see all those zeros? Let's count them. 1, 2, 3, 4, 5, 6. We can use the power of 10 to rewrite this number instead of writing out all those zeros. Instead, we can take all the digits in front of the zeros, or 348, and multiply it by 10 to the power of 6, because there were 6 zeros. An even bigger number is there are 30 trillion human cells inside each human body. Look at all those zeros. When we count each of those up, we're actually going to get 13 zeros. So using powers of 10 will help us write this number a little bit more compact. We'll take that number in front, which is just a 3, and multiply it by 10 to the power of 13. I can do this in reverse as well. Say we start with a number that's written in exponent form. 22 times 10 to the power of 7. And that represents the number of soccer balls that are produced each year. Because I know that 7, or exponent number, is telling me the number of zeros in the number, I can write this out in standard form by bringing my 22 down. I know the decimal point is right behind it. And I'm just going to slide that decimal place over 7 places and fill them in with zeros, because that's what that power of 7 is representing. And so now I can more clearly see that 220 million soccer balls are produced each year. So in summary, powers of 10 allow us to write really big numbers just by using multiples of 10 and exponents. Thank you for watching, and if you're interested in learning more about TurtlEd, you can visit us at withturtled.com.